Question 1. In the context of Ista Ramirez managing a commercial building's HVAC system, the facility recently installed demand-controlled ventilation (DCV) system that uses COS sensors to adjust fresh air intake. After several weeks, occupants complain of stale air during peak occupancy. What is the most probable cause and best corrective action? A. The COS sensors are likely malfunctioning or improperly calibrated. Recalibrate or replace the sensors to ensure accurate ventilation control. B. The system is providing excessive fresh air, causing drafts. Reduce the ventilation set points to lower intake. C. The DCV system is set to maintain constant ventilation regardless of CO levels. Change the control strategy to modulate based on occupancy. D. The ventilation's ductwork is undersized. They increase duct diameter to improve airflow delivery. Answer. Correct answer. A. Explanation. DCV relies on accurate COS sensing to modulate ventilation based on occupancy. Malfunctioning or poorly calibrated sensors cause incorrect readings, leading to insufficient fresh air and stale conditions. Reducing ventilation set points without diagnosing sensor issues risks indoor air quality violations. Maintaining constant ventilation defeats DCV purpose and wastes energy. Duct sizing affects volume but is unrelated if ventilation is controlled incorrectly at the sensor level. Recalibration ensures reliable, adaptive ventilation aligning with occupancy changes. Question 2. Given the circumstances, Lee is tasked with selecting a refrigerant for a new commercial ERF system. She must minimize environmental impact without compromising system efficiency. Which refrigerant characteristic is the most critical to prioritize in her selection? A. Low flammability and toxicity to ensure safe operation. B. High global warming potential due to maximized cooling capacity. C. Low ozone depletion potential and debut reduce environmental harm. D. High pressure and temperature levels for compatibility with existing compressors. Answer. Correct answer. C. Explanation. Minimizing environmental impact requires choosing refrigerants with lower and debuted characteristics reduce harm to the ozone layer and global climate. High flammability or toxicity may be concerns but often can be managed through system design and safety protocols. They are secondary to environmental impact for green HVACR systems. HVAC contradicts environmental goals and pressure and temperature properties relate to equipment design rather than sustainability priorities. Question 3. Considering the evidence, Ista Patel is reviewing energy audit results for a multi-zone HVAC system. The audit suggests high energy consumption due to simultaneous heating and cooling in adjacent zones. Which of the following strategies is most effective to reduce this inefficiency? A. Installing variable frequency drives VFDS on all fans to reduce motor energy use. B. Balancing air distribution to ensure equal airflow to all zones. C. Implementing zone sequencing controls to prevent simultaneous heating and cooling. D. Increasing thermostat set points across all zones to reduce cooling load. Answer. Correct answer. D. Explanation. Simultaneous heating and cooling in adjacent zones often results from poorly coordinated control strategies. While VFDS save fan energy, they don't resolve conflicting thermal demands. Balancing airflows improves comfort but does not stop simultaneous conditioning. Zone sequencing controls can reduce conflicts, but adjusting thermostat set points strategically reduces overall load and prevents unnecessary cooling, thereby improving efficiency. Proper thermostat set points minimize energy waste while maintaining comfort. Question 4. While examining a building with geothermal heat pump systems, Johnson observes fluctuating loop water temperatures affecting system efficiency. What is the most likely cause and what corrective action should be taken? A. Incorrect loop sizing causing thermal imbalance. Redesign the loop to meet load requirements. B. Poor heat exchanger fouling in the indoor unit. Clean or replace the heat exchanger. C. Insufficient refrigerant charge in the heat pump. Add refrigerant to correct charge. D. High building infiltration rates. Improve building envelope tightness. Answer. Correct answer. C. Explanation. Fluctuating loop temperatures often indicate improper refrigerant charge affecting heat transfer efficiency in geothermal heat pumps. Incorrect loop sizing causes steady inefficiency rather than fluctuations. Fouling inside the indoor heat exchanger leads to consistent performance degradation, not temperature swings. Infiltration impacts building load but not loop water temperature fluctuations directly. Correct refrigerant charge is essential for stable operation and optimal heat transfer between the geothermal loop and indoor system. Question 5. From a practical standpoint, Mr. O'Neill installs solar thermal system to provide supplemental hot water for his facility's HVAC heating. After installation, the system's performance is below expectations. What is the primary factor he should evaluate to improve efficiency? A. The orientation and tilt angle of solar collectors relative to the sun's path. B. The insulation thickness of the building's walls. C. The refrigerant type used in the existing HVAC chillers. D. The ventilation rates inside the building. Answer. Correct answer. D. Explanation. Solar thermal efficiency strongly depends on solar collector placement, orientation and tilt. But if the hot water demand or heat loss from ventilation is excessive, system performance suffers. Ventilation rates impact overall heating load by allowing heat to escape, which affects supplemental heating demand. Insulation thickness and refrigerant type have minimal direct impact on solar thermal system efficiency. Optimizing ventilation to minimize heat loss complements solar thermal effectiveness. Question 6. Illustrated by a recent retrofit project, Kim is evaluating potential benefits of upgrading to a building automation system BAS. Which of the following is the most compelling advantage of implementing a BAS in terms of green HVACR principles? A. Simplifies system operation by removing all manual overrides. B. Provides real-time data to optimize energy use and proactively detect faults. C. Guarantees 100% renewable energy use through automated controls. D. Eliminates the need for preventive maintenance on HVAC equipment. Answer. Correct answer. B. Explanation. BAS enhances sustainability by offering real-time monitoring, allowing optimization of energy consumption and early fault detection to avoid inefficiencies and system failures. It doesn't remove manual overrides entirely. Operator input remains crucial. BAS alone cannot guarantee full renewable energy use. Integration with renewables is required. Preventive maintenance remains necessary despite BAS, as physical component upkeep cannot be fully automated. Question 7. With respect to refrigerant leak detection, Mr. Davis is tasked with implementing an effective program in a large refrigeration system to comply with environmental standards. Which approach best balances leak minimization and operational efficiency? A. Performing quarterly manual leak checks only when system pressure drops are detected. B. Installing continuous electronic leak detectors combined with scheduled maintenance. C. Relying solely on pressure gauges to indicate leaks during normal operation. D. Waiting for visible oil stains before initiating repair to avoid unnecessary downtime. Answer. Correct answer. C. Explanation. Relying only on pressure gauges is insufficient because pressure drops may occur after significant leaks have already released refrigerant. Quarterly manual checks alone risk missing leaks between inspections. Waiting for visible oil stains delays detection and increases environmental damage. Continuous electronic detectors combined with scheduled maintenance provide proactive leak detection and prompt repair, minimum refrigerant emissions and maintaining efficiency. Question 8. During the process of commissioning a new variable refrigerant FO VRF system, Garcia notices uneven temperatures across zones despite the system running at design capacity. Which is the best next step to diagnose and correct the problem? A. Verify refrigerant charge and ensure proper distribution among indoor units. B. Replace the outdoor unit with a higher capacity model. C. Reduce thermostat set points uniformly to compensate for temperature differences. D. Increase supply air velocity in all ductwork. Answer. Correct answer. D. Explanation. Uneven temperatures in ERF systems often stem from improper airflow delivery. Adjusting supply air velocity can help balance temperatures across zones. Verifying refrigerant charge is important, but uneven zone temperatures usually relate to airflow distribution. Replacing outdoor units is premature without confirming the root cause. Reducing thermostat set points globally may lower comfort and energy without resolving airflow issues. Question 9. Taking into account recent advancements, which of the following best describes the core environmental benefit of switching from traditional refrigerants to natural refrigerants like or hydrocarbons? A. They operate at much lower pressures, reducing mechanical stress on components. B. They have negligible ozone depletion potential and very low global warming potential. C. They require less frequent maintenance due to their chemical stability. D. They provide inherently higher cooling capacities, improving system performance. Answer. Correct answer, C. Explanation. Natural refrigerants have very low or zero ozone depletion and minimal global warming potential, reducing environmental harm significantly. Operating pressures vary. For example, operates at higher pressures. Maintenance frequency depends on system design and usage, not solely refrigerant chemistry. Higher cooling capacity depends on application specifics and is not an inherent universal benefit. The primary environmental advantage is minimal ozone and climate impact. Question 10. Throughout the course of a green building project, ISTASing must ensure compliance with ventilation standards while minimizing energy consumption. What is the best strategy to achieve this balance? A. Increase ventilation rates to maximum levels during all occupied hours. B. Use demand-controlled ventilation based on occupancy and air quality sensors. C. Seal the building completely to eliminate outdoor air infiltration. D. Disable ventilation systems during unoccupied periods to save energy. Answer. Correct answer, B. Explanation. Demand-controlled ventilation adjusts fresh air intake based on real-time occupancy and air quality, maintaining indoor air quality while minimizing energy wasted on conditioning excess air. Constant maximum ventilation wastes energy unnecessarily. Complete sealing risks poor air quality and potential health issues. Disabling ventilation entirely when unoccupied can be safe if controlled properly. Demand-controlled systems provide more refined, continuous efficiency. Question 11. Taking into account the evidence, ISTACHEN oversees the installation of a geothermal heat pump system in a new office building. After commissioning, he notices the loop temperature remains unusually high during cooling mode, reducing system efficiency. What is the most likely cause and corrective measure? A. The geothermal loop is undersized, causing insufficient heat rejection. Resize and install a larger loop field. B. The refrigerant charge in the heat pump is excessive. Reduce refrigerant to improve heat transfer. C. The indoor air handler's filter is clogged, restricting airflow. Replace or clean the filter. D. The building envelope has excessive infiltration. Tighten the building to reduce cooling load. Answer. Correct answer, A. Explanation. An undersized geothermal loop limits heat rejection capacity, causing elevated loop temperatures that reduce system efficiency in cooling mode. Excess refrigerant typically causes other symptoms like high pressure, not loop temperature rise. A clogged filter reduces indoor airflow but does not directly affect loop temperatures. Building infiltration impacts cooling load but does not cause loop temperature anomalies. Sizing the geothermal loop ensures adequate heat transfer with stable loop temperatures. Question 12. In the context of Is Davis managing a commercial ERF system, she notices frequent compressor cycling leading to energy waste. Which control strategy is best suited to mitigate this issue and improve system efficiency? A. Implement minimum runtime settings to avoid short cycling of compressors. B. Increase the thermostat deadband to widen temperature control range. C. Install additional expansion valves to balance refrigerant flow. D. Use manual thermostats instead of digital controls for simplicity. Answer. Correct answer, B. Explanation. Increasing the thermostat deadband reduces frequent compressor cycling by allowing wider temperature fluctuations before activating equipment, thus improving efficiency. Minimum runtime settings also help but may prolong compressor operation unnecessarily if deadband is narrow. Expansion valves regulate refrigerant flow but do not control compressor cycling. Manual thermostats lack precision and may worsen cycling. A well-tuned deadband balances comfort with energy savings. Question 13. From the perspective of reducing refrigerant leaks in a large HVAC system, what is the most effective practice to implement? A. Conduct continuous electronic leak monitoring combined with prompt repairs. B. Perform leak inspections only during annual preventive maintenance. C. Wait for system pressure drops before initiating leak detection procedures. D. Use refrigerants with higher pressure to minimize leak potential. Answer. Correct answer. D. Explanation. Using higher pressure refrigerants generally increases leak risk, not reduces it. The best practice involves continuous leak monitoring with electronic sensors and rapid repair to minimize refrigerant loss and environmental impact. Inspections only during annual maintenance can miss leaks for months, increasing emissions. Waiting for pressure drops delays leak detection. Proactive monitoring combined with repairs, effective refrigerant management. Question 14. Based on the information about a retrofit project, Mr. Wilson decides to replace an old chiller with a high-efficiency model rated by EAR and IPOV. Which factor most accurately reflects the benefit of this upgrade? A. Lower IPOV indicates better part load efficiency, reducing energy use during typical operation. B. Higher EAR means improved efficiency only during peak load conditions. C. EAR and IPOV ratings have no impact on energy consumption or operating cost. D. Higher EAR reduces first cost but increases operating expenses. Answer. Correct answer. B. Explanation. The energy efficiency ratio measures efficiency at a fixed peak load condition, so higher EAR means better efficiency at peak loads. IPOV, integrated part load value, measures performance at part load conditions, which are more common in operation. A lower IPOV is not beneficial. Lower values mean poorer performance. Ratings directly impact energy use and cost, with higher EAR reducing expenses. Higher EAR generally increases equipment cost but lowers operating expenses. Question 15. With respect to energy efficiency in HVAC system design, Martinez is evaluating variable frequency drives VFDS for fan motors. What principle justifies the use of VFDS in this application? A. Fan power consumption varies approximately with the cube of airflow velocity, so reducing speed saves significant energy. B. VFDS maintain constant airflow regardless of system demand. C. VFDS increase motor speed to meet peak ventilation needs at all times. D. Fan motors consume the same energy regardless of speed. O. VFDS provide only operational flexibility. Answer. Correct answer. A. Explanation. Fan power varies roughly with the cube of airflow velocity, meaning small reductions in speed yield large energy savings. VFDS allow precise speed control to match demand. Saving energy. VFDS do not maintain constant airflow at all times. They modulate airflow. Increasing motor speed constantly wastes energy. Motor energy use varies with speed. VFDS effectively reduce power consumption to low demand. Question 16. As demonstrated by a recent energy audit, Mr. Lopez notices high latent loads in a commercial building, leading to humidity issues. Which HVACR approach best addresses this problem while maintaining energy efficiency? A. Increasing ventilation rates to maximum levels continuously. B. Using dedicated outdoor air systems DOAs with energy recovery ventilators. C. Reducing the size of cooling coils to increase dehumidification. D. Relying solely on space air conditioners to control humidity. Answer. Correct answer. C. Explanation. Oversizing cooling coils can reduce latent load handling because air passes too quickly for moisture removal. Reducing coil size or providing dedicated dehumidification allows better moisture extraction. Increasing ventilation rates indiscriminately adds humidity and energy cost. DOAs with ERV improves ventilation efficiency but does not directly address latent load unless coupled with dehumidification. AC units may not provide sufficient humidity control alone. Correct coil sizing and dedicated dehumidification balance humidity control with efficiency. Question 17. Within the framework of refrigerant regulations, Thompson plans to upgrade the facility's refrigerant to DIDUP alternative. What is the critical compliance consideration she must prioritize? A. Ensuring the new refrigerant's compatibility with existing system components and lubricants. B. Selecting the refrigerant with the highest flammability rating for better cooling. C. Choosing refrigerant with the same op as the current one to maintain system safety. D. Ignoring refrigerant recovery requirements during retrofit to save costs. Answer. Correct answer. A. Explanation. Compatibility with existing components and lubricants is critical when changing refrigerants to avoid system damage or failure. High flammability refrigerants pose safety risks and require special handling, so highest flammability is not preferred. Ozone depletion potential should be minimized, not maintained at existing levels. Refrigerant recovery is legally required during retrofit to prevent environmental damage and comply with regulations. Ignoring this risks penalties. Question 18. When considering green building principles ISTA designs a HVAC system for a LEED certified project, what HVAC design strategy most effectively contributes to achieving LEED energy credits? A. Using oversized equipment to guarantee performance under all conditions. B. Integrating energy recovery ventilators and demand-controlled ventilation. C. Minimizing insulation to reduce material costs. D. Using standard efficiency equipment with manual controls. Answer. Correct answer. D. Explanation. LEED credits reward energy efficiency through smart design, including energy recovery ventilators and DCV to reduce energy waste. Oversizing equipment leads to inefficiency and wasted energy, contrary to green principles. Minimizing insulation increases heat loss gain, reducing efficiency. Standard efficiency equipment with manual controls limits optimization opportunities. Proper sizing and advanced controls are essential for LEED compliance. Question 19. From a practical standpoint, Alan notices that the building's heat recovery system is not delivering expected energy savings. Which issue is the most common cause of poor heat recovery performance? A. Incorrect bypass damper settings allowing heated or cooled air to escape. B. Oversized heat exchangers limiting heat transfer. C. Using glycol instead of water in the loop for heat transfer. D. Operating the system only during unoccupied periods. Answer. Correct answer. A. Explanation. Incorrectly set bypass dampers can divert air around heat recovery units, reducing their effectiveness. Oversized heat exchangers usually improve, not limit, heat transfer. Glycol is often used to prevent freezing and does not inherently reduce heat transfer efficiency significantly. Operating heat recovery only when the building is unoccupied limits energy savings. A continuous operation during occupied periods maximizes benefit. Question 20. In light of recent developments, ISTA Garcia evaluates the environmental benefits of replacing R22 refrigerant with R400 TINA in an existing system. Which factor best describes the improvement achieved by this replacement? A. R400 TINA has zero ozone depletion potential, reducing damage to the ozone layer. B. R400 TINA has a significantly lower global warming potential than R22. C. R400 TINA allows use of existing oil and components without modifications. D. R400 TINA is less efficient than R22 but safer to handle. Answer. Correct answer. B. Explanation. R400 TINA does have zero ozone depletion potential, which is an improvement over R22, which has a moderate so that is true, but the key factor widely cited is R400 TINA's substantially low debut compared to older refrigerants like R22, which reduces climate impact. R400 TINA requires system modifications and uses different lubricants, so it is not directly compatible with R22 systems. R400 TINA is generally more efficient than R22, and safety characteristics depend on application and handling procedures. Question 21. When evaluating a high-efficiency chiller upgrade for a hospital, Roberts notices that the proposed unit's IPV is substantially better than its IR. What does this suggest about the unit's operational efficiency? A. It will perform better under part load conditions than at peak load. B. It will perform better at peak load than under part load conditions. C. It will consume less energy regardless of load conditions. D. It will operate at maximum efficiency only when oversized. Answer. Correct answer. A. Explanation. A high IPV compared to IR indicates strong part load performance, which is valuable in systems that rarely run at full load. Hospitals typically have varying demand, so part load efficiency greatly impacts annual energy use. High IPV alone reflects peak load efficiency. Assuming less energy use at all loads ignores varying operating profiles. Oversizing reduces efficiency by increasing cycling losses. Optimizing IPV is often more impactful in real-world HVAC operations than peak IR. Question 22. Given the circumstances, ISTA-CON is troubleshooting a geothermal system where heat extraction capacity has dropped during winter, which causes most likely A. The loop field has become partially frozen, restricting heat transfer. B. The air handler blower speed is set too high for heating mode. C. The outdoor condensing unit is oversized for the load. D. The refrigerant type has too low a pressure for heating operation. Answer. Correct answer. B. Explanation. In heating mode, excessively high blower speed can reduce air to refrigerant heat transfer time, lowering supply air temperature and system efficiency. Partial freezing in a properly designed loop is rare unless antifreeze concentration is inadequate. Oversizing outdoor units applies to conventional systems, not closed-loop geothermal. Refrigerant pressure characteristics are determined during design. Efficiency lost here points more to airflow mismatch than refrigerant properties. Question 23. The fundamental question is in a large office tower using a demand-controlled ventilation D/V system, why might CO levels still exceed standards during peak occupancy? A. The outdoor air damper is undersized for maximum airflow needs. B. The D/V sensors are installed near supply diffusers, reading diluted air. C. The return fan is oversized, creating negative pressure in occupied spaces. D. The air handling unit is operating below design airflow during high occupancy. Answer. Correct answer. C. Explanation. Improper sensor placement near supply air can give falsely low readings, delaying fresh air introduction. Oversized return fans can overdraw air, creating negative pressure and limiting outdoor air delivery, allowing CO to rise. Damper undersizing limits maximum ventilation rate but would cause chronic rather than peak-only issues. Low OHU airflow reduces ventilation but would typically be identified in commissioning, and negative pressure impacts both comfort and IAC during high load periods. Question 24. While examining an energy audit for a university, is green notes simultaneous heating and cooling in a variable air volume VEV system? Which control modification would address this without sacrificing comfort? A. Increase reheat coil activation thresholds. B. Reduce supply air temperature reset range. C. Implement supply air temperature reset based on outdoor temperature. D. Disable all terminal reheat coils during summer months. Answer. Correct answer. C. Explanation. Supply air temperature reset allows warmer supply air when outdoor temperatures are mild, reducing unnecessary cooling and reheat. Increasing coil activation thresholds helps but doesn't adjust central plant output. Narrowing reset range may worsen energy waste. Disabling reheat coils entirely risks comfort in perimeter zones even in summer due to solar load variations. Resetting supply air temperature aligns central terminal unit operation for efficiency. Question 25. In light of recent developments, ISTA Ortega is considering a refrigerant change to R32 for a rooftop unit. What is a primary design consideration? A. R32's flammability classification requires enhanced leak management and safety measures. B. R32's acidity requires specialized environmental permits. C. R32 operates at lower pressures than R400 TINA, reducing compressor workload. D. R32 is incompatible with all existing copper piping in HVAC systems. Answer. Correct answer. A. Explanation. R32 has an R classification, meaning it's mildly flammable and requires specific leak detection, ventilation, and charge size considerations. It actually has led to debut with an R400 TINA, making it environmentally preferable. It operates at similar or slightly higher pressures than R400 TINA, not lower. Copper piping compatibility is generally good for R32. The design challenge is safe handling and installation to meet safety codes and minimize ignition risk. Question 26. In terms of renewable integration, is Silver wants to use solar PV to offset HVAC electricity use. Which approach maximizes both energy efficiency and renewable utilization? A. Connect PV output directly to HVAC motors without inverters. B. Install PV with grid-tied inverters and use high-efficiency HVAC equipment. C. Oversize PV raise to cover HVAC demand exclusively. D. Operate HVAC only during peak solar generation hours. Answer. Correct answer. B. Explanation. Grid-tied PV with inverters allows full use of solar energy for all building loads while feeding excess to the grid, paired with high-efficiency HVAC for reduced overall demand. Direct motor connection without inverters is not feasible for modern equipment. Oversizing PV may not be cost-effective and wastes generation during low demand. Restricting HVAC to solar hours compromises comfort and may increase overall energy cost if supplemental systems are needed. Question 27. According to recent studies, Mr. Howard notices occupants complaining of dryness in a high-efficiency office HVAC system during winter. What adjustment best addresses this while maintaining efficiency? A. Increase humidification using a steam humidifier integrated with the ventilation system. B. Reduce ventilation rates to retain indoor moisture. C. Lower supply air temperature to increase relative humidity. D. Switch to constant volume operation to stabilize humidity. Answer. Correct answer. C. Explanation. Lowering supply air temperature can increase relative humidity without adding energy-intensive humidification, provided dew point remains above freezing risk. Increasing humidification adds comfort but at significant energy cost. Reducing ventilation harms indoor air quality. Constant volume operation reduces efficiency and does not directly improve humidity control. Proper supply air temperature adjustment improve comfort while keeping energy use low. Question 20. From a historical standpoint, why is R744 Co becoming more popular in commercial refrigeration despite its high operating pressures? A. It is non-toxic and has zero global warming potential. B. It has zero ozone depletion potential and it is compatible with all existing refrigerant oils. D. It requires smaller compressor displacement for equivalent capacity. Answer. Correct answer. D. Explanation. Co has zero ozone depletion potential and but its main adoption driver includes efficiency improvements in certain climates and the fact that high volumetric capacity allows smaller compressor displacement for equivalent cooling. It is not fully non-toxic at all concentrations, and it does have low but none debut compatibility with existing oils varies and may require changes. The high pressure challenge is balanced by its environmental and efficiency benefits. Question 29. The impact of poor duct insulation in a high-performance building is often underestimated. Which is the most significant consequence for green HVAC operation? A. Increased fan motor wear due to higher air velocities. B. Elevated thermal losses reducing system efficiency. C. Condensation damage to duct materials only in winter. D. Need for oversized diffusers to maintain comfort. Answer. Correct answer. B. Explanation. Poor duct insulation leads to heat gain loss along duct runs, increasing system energy use and reducing delivered comfort conditions. Fan wear relates more to static pressure and velocity, not insulation. Condensation can occur in multiple seasons, not only winter, and is secondary to energy loss. Diffuser sizing is determined at design stage and is unaffected by insulation degradation. Effective duct insulate, essential to preserving green system efficiency. Question 30. By evaluating operational data, Foster determines that the building's chilled water plant is most efficient at 70% load. Which control strategy maximizes this efficiency? A. Stage chillers to operate the most efficient units at higher load factors before starting additional units. B. Maintain all chillers running at equal part load conditions. C. Use only the largest chiller for all load conditions. D. Cycle chillers on and off rapidly to match fluctuating demand. Answer. Correct answer. A. Explanation. Loading the most efficient chiller to its optimal load range before starting others maximizes plant efficiency. Equal part load operation may keep all units below optimal performance range. Using only the largest chiller for all conditions risks cycling inefficiencies. Rapid cycling increases wear and decreases efficiency. Strategic staging matches demand with peak performance conditions of the most efficient units.